Okay, we've got to find the equation of the normal to the curve with equation y equals 8 minus 3 root x at the point where x equals 4. So let's draw a diagram to help us here. We've got this curve here, which incidentally is the curve here, and we're being asked for the equation of the normal to the curve at the point where x equals 4. Well, the point where x equals 4 is labelled A here, isn't it? So while we're at it, we might as well just work out the y-coordinate of that point. I know we can see it from the graph, but of course we're not supposed to be using a graph plotter. So we best take x equals 4 and work out what the y-coordinate of that point is. It's going to be 8 minus 3 times root 4, which is 8 minus 3 2 is 6, which is 2. So y equals 2. So the point is indeed the point 4. We knew that already, of course, by looking at the graph. Now, we've got to find the equation of the normal. Now, let's just have a think about this. I know we could have a tangent to the curve at that point, and lo and behold, here is a diagram with the tangent marked. Remember, this is the point A, which is the point 4, 2, and there's the tangent. And the tangent, of course, has the same gradient as the blue curve at that point. But we don't want the equation of the tangent, we want the equation of the normal. So here, where's it gone? Here is a third diagram, shows you the point A, 4, 2, and you can see the tangent, the black line, and there's the normal at the point A, the point which crosses at right angles there. Now, how are we going to find the equation of the red line? Well, we know a point on the red line already, the point 4, 2, but we need to know the red line's gradient. I can't find the red line's gradient, but I can find the gradient of the black line, because the black line is the tangent to the curve at the point A, so it shares the same gradient as the curve at that point A. Now, the curve has equation y equals 8 minus 3 root x, so I can differentiate that, and that will enable me to find the gradient at the point A. So dy by dx is going to be 8 differentiates to 0, and so I've got a half times minus 3, so that's minus 3 over 2 times by x, the minus a half. That's what it differentiates to. That's the gradient function. I want to know the gradient when x equals 4. Let's have a look. If x equals 4, then dy by dx equals minus 3 over 2 multiplied by, that's 1 over the square root of 4. Well, the square root of 4 is 2, of course. So this works out to minus 3 over 4. So the gradient of this tangent, which I'll call m1, is minus 3 over 4. So that means that I can find the gradient of the red line, the gradient of the normal, because the normal and the tangent are perpendicular to each other. So the gradient of the red line, which I'll call m2, is the negative reciprocal of the gradient of the tangent, the black line. So now, to find the equation of the red line, I know the red line's gradient, and also I know a point on the line. So I can find the equation of the red line, the equation of the tangent of the normal to the curve at that point. Y minus y1 equals m x minus x1. Y minus 2 equals 4 over 3 x minus 4. Multiply both sides by 3. 3y minus 6 equals 4 lots of the bracket. 3y minus 6 equals 4x minus 16. How should we write it? Let's write it as 3y minus 4x, and let's add 16 to both sides, equals 0. And there is the equation of the red line. That's the equation of the normal to the curve when x equals 4.